Hello everyone, good morning to all. This is Sunita Yadav, your science teacher. In today's class, we discuss chapter number 16 in your NCERT book. The chapter name of this chapter is light. Light is a form of energy, okay? And without light, we can't able to see anything, okay? And how we see any object whenever sunlight reflect the when sunlight fall on the any object and then particular object reflect the sunlight in all direction. This reflected light when enter in our eyes, we able to see objects. हमें जो है objects को देखने में easy रहता है. Okay. Next we understand about the activity 16.2. In dark room we can't able to see anything. Why? Because no light is there, no reflection is there. Okay, so first thing is understand in this chapter what is reflection. What is reflection? The process of sending the light. The process of sending the light ray back is known as a reflection of light. जो भी light है उसको वापस sending back करना, ठीक है. और इसी फिनोमेना को हम बोलते हैं reflection of light. Okay. Reflection is the phenomena bouncing back the light in the same medium. जो reflection है उसको हम क्या बोलते हैं? Same medium के अंदर जो light आ रही है उसको वापस से bounce back करना, that is called the reflection. Okay. Now we move to a next topic, law of reflection. We discussed first activity in previous class. Then we understand what is incident ray and what is reflected ray. What is incident ray? The ray of light which fall on the mirror in reflective. जो लाइट रिफ्लेक्ट कम सूर्य कहाँ पर मिरर के पास में आ रही है, ठीक है ना. तो द लाइट फॉल ऑन द मिरर रिफ्लेक्टर सरफेस इज कॉल्ड द इंसिडेंट रे एंड दैट लाइट बाउंस बैक एंड रिफ्लेक्ट अगेन through a mirror is called a reflected ray. And the reflected ray जो center के अंदर जो point बन रहा है बिल्कुल center में, the point at which the incident ray strike the reflecting surface of the mirror is called a point of incidence. This one is point of incidence. Here is when we draw a right angle means 90-degree angle. This ray is called a normal ray. Okay. And then we understand about the angle of incidence. What is angle of incidence? The angle which incident ray make with the normal ray. Normal ray and incident ray के बीच में जो angle बनता है, it is called the incident ray. And that particular angle, reflected ray and with the normal ray. ऐसा angle जो reflected ray और normal angle के बीच के साथ में बनता है, it is called a reflected angle of reflection. Okay, तो दो हमने पढ़े, एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्लेक्शन. एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्लेक्शन के रिगार्डिंग ये मैं रिपीट इसलिए करवा रही हूँ बेटा क्योंकि ये कंसेप्ट क्लियर होना बहुत जरूरी है, तभी हमें आगे की चीजें प्रॉपर्ली समझ में आएंगी. ठीक है. देन हमने एक एक्टिविटी और की थी जिसमें हमने देखा था कि हम डिफरेंट एंगल लिए. हमने इंसिडेंट एंगल्स सपोज 30, 50, 40, तो वी ऑब्जर्व दैट 30 इंसिडेंट एंगल है, then reflected angle भी 30, 40 incident angle है तो 40 the angle of reflections. Okay, so always angle of incident equal to angle of reflection. देखिए law of reflection में हमने two things read करी है. First thing, incident ray जिस medium से enter होगी उसी medium में reflect होगी. Okay, then angle of incident and angle of reflection always equal. Okay, now we move to a one second. Next activity, activity 16.2. We discuss this activity. First we saw this video. Okay, I think we're more able to understand this point.
I can't see anything.
Here you go.
Why do you think Tina couldn't see anything in the dark, even with her eyes open? Clearly, just the eyes are not enough to see. We can see only when light emitted by or reflected from an object enters our eyes. In this lesson, you will learn about reflection of light in plane mirrors and multiple reflections. At the end of this lesson, you will be able to identify the laws of reflection, identify the characteristics of images formed in plane mirrors, differentiate between diffused and regular reflection. Explain how reflected light can be reflected again. And demonstrate that sunlight is formed of several colors.
Hey, Tina, look here.
Ouch! What are you doing? Stop that!
James has figured out a way to direct sun rays towards Tina and is having fun teasing her. Hey James, Tina.
Hey,
I see you're having a good time.
yeah, this mirror game is cool.
Sure it is. However, do you know that this game uses the phenomenon reflection of light?
Well, I can definitely see he's using sunlight to tease me. So, what exactly is reflection of light?
The bouncing back of light incident on an object into the same medium through which it is incident on the object is called reflection of light.
Bouncing back of light?
Sounds confusing? Well, let me start from the basics. You are aware that light travels in straight lines, right?
Yes, we learned that in school.
The path along which light travels is called a ray of light. A ray of light is generally represented by a directed line segment. A collection of light rays is called a beam of light.
So, James was directing a beam of sunlight at me?
Yes, he was able to direct the beam using the laws of reflection. Light rays follow two laws of reflection. They are: the angle of incidence is always equal to the angle of reflection. The incident ray, the normal at the point of incidence, and the reflected ray lie in the same plane. However, that's a lot of jargon. Let's carry out an activity to understand the basic terms related to reflection and then prove the first law of reflection. We will need a plain mirror, a torch, a cardboard with a very narrow rectangular slit, white sheets of paper, pencil, adhesive tape, a protractor, and a set square.
There you go.
Good. Let's start with our activity. At the center of the light beam from the torch. We place the lit torch on. We fix the white sheet of paper with our activity. First, we fix the white sheet of paper on a table with the adhesive tape, so that a portion of the paper protrudes outside the table. We fix the cardboard on this sheet of paper. Then, we place the lit torch on the table and adjust it in such a way that the streak of light from the rectangular slit is seen along the white paper. The rectangular slit should be at the center of the light beam from the torch. Finally, we place a small strip of mirror in the path of the light ray. So, what do you see?
The light ray strikes the mirror and reflects in another direction.
Right. Something like what you were doing in your game. The light ray from the source of the reflecting surface is called the incident ray.
So in this case, the light ray from the torch hitting the mirror is the incident ray.
That's right. The light ray that bounces off the reflecting surface in another direction is called the reflected ray.
Are you referring to the ray that is reflected back from the mirror?
Exactly. Let's continue with our activity. Now, we draw a line on the paper along the mirror to mark its position. we mark some points on the path of the incident ray from the torch to the mirror. Similarly, we mark the path of the reflected ray. Now, let's remove the torch, cardboard, and mirror and join the points. Can you see where these lines intersect?
Interesting. The lines drawn along the paths of the incident and the reflected light rays intersect at a point on the line we drew to indicate the plane mirror.
The point at which the incident ray strikes the reflecting surface is called the point of incidence. Next, we draw a perpendicular to the line representing the mirror at the point of incidence by using the set square. This line is called the normal. Can you see how the other lines form angles with the normal?
Yes, both the reflected ray and the incident ray form angles with the normal.
The angle between the incident ray and the normal is called the angle of incidence. It is represented by the letter I. The angle between the reflected ray and the normal is called the angle of reflection. It is represented by the letter R. Now compare the angle of incidence and the angle of reflection using a protractor. Which one seems bigger?
Neither. Both angles seem to measure the same.
Correct. That's because the angle of incidence is always equal to the angle of reflection. Now let's look at the second law, which states the incident ray, the normal at the point of incidence, and the reflected ray lie in the same plane. We will slightly modify the setup that we used in the previous activity. Consider the portion of the white paper that extends beyond the edge of the table. Initially, you can see that the reflected light rays are on this portion of the paper, right?
Right. Now, fold the paper downwards along the edge of the table. What do you observe? Can you see the reflected light ray on the portion of the paper that has been folded downward?
No, it is not visible now.
This is because the bent portion of the paper is now in a different plane. That is, the vertical plane. Thus, the plane of the reflected ray is different from that of the incident ray.
I get it. When the paper was spread straight along the surface of the table, it was on the same plane as that of the light ray incident on the mirror. The incident ray, reflected ray, and the normal, all the three were in the same plane. When the paper was folded, it went to a different plane, and so the reflected ray was not visible on that part of the paper. So that was the secret behind the trick James was playing on me?
Yes. Now that you know the laws, you can explore them and create tricks of your own.
आई होप आपको एक्टिविटी 16.2 क्लियर हुई होगी. हम लाइन टू लाइन लर्न कर लेते हैं, कोई भी पॉइंट रह गया होगा तो. परफॉर्म एक्टिविटी 16.1 अगेन, जो हमने 16.1 की थी, जिसमें इंसिडेंट रे एंड रिफ्लेक्टेड रे को अंडरस्टैंड किया था. This time you use a sheet, stone paper or a chart paper. Let the sheet project a little beyond the edge of the paper. Cut the projecting portion of the sheet in the middle. Look at the reflected ray. Make sure that the reflected ray extend to the projected portion to the paper. Bend that part for the projected portion and on which the reflected ray fall. Can you still see the reflected ray? Bring the paper back to the original form. Just a minute. Just look at this. अब देखिए सेम पहले जैसे ही प्रैक्टिकल कर रहे हैं कि हम टॉर्च की हेल्प से कॉम के बीच में से एक इंसिडेंट रे पास कर रहे हैं, देन मिरर से स्ट्राइक होकर वो रिफ्लेक्टेड रे बन रही है. अब हम क्या करते हैं, यहाँ पे इसको बिल्कुल सेंटर से इस जगह से सीजर की हेल्प से कट कर देंगे एंड इस पेपर को नीचे की तरफ बेंड कर देंगे. ओके, when जैसे ही हम बेंड करते हैं we observe that जो reflected ray है बेंड होने के बाद में आगे हमें ऑब्जर्व नहीं होते. दैट मीन्स क्या हुआ, सेकंड लॉ ऑफ रिफ्लेक्शन क्या हुआ, सेकंड लॉ ऑफ रिफ्लेक्शन ये हुआ कि इंसिडेंट रे, नॉर्मल रे एंड रिफ्लेक्टेड रे, ठीक है, ऑल थ्री रेज आर फाउंड इन अ सेम प्लेन, एक ही प्लेन पे होते हैं. जैसे ही हमने उस पेपर को फोल्ड किया मींस उसका एक्सिस चेंज कर रहे हैं, हम वाई एक्सिस पे ले जा रहे हैं, ठीक है, तो उसको उस अदर प्लेन करते ही हमें वहां पर रिफ्लेक्टेड रे ऑब्जर्व नहीं होती है. तो हियर इज टू law of reflection. When the whole sheet of paper is spread on the paper, it represents one plane, the incident ray, normal at the point of incident, and the reflected ray all in a same plane. Okay. When you bend the paper, you create a plane pair different from the plane in which the incident ray and the normal lie, and you do not see the reflected ray. What do you incident? It indicates that the incident ray, the normal ray, at the point of incident, reflected ray all in the सेम प्लेन. ओके, तो हमने कौन कौन से दो पॉइंट लॉ ऑफ रिफ्लेक्शन के अंदर लिख के, फर्स्ट मेन जो दो टू लॉ ऑफ रिफ्लेक्शन है, फर्स्ट वन इज द एंगल ऑफ इंसिडेंट इज इक्वल टू एंगल ऑफ रिफ्लेक्शन. ओके, नेक्स्ट थिंग इज the incident ray, the normal at the point of incident, and the reflected ray all lie in a same plane. I hope it's clear to you. अभी तक आपको व्हाट इज रिफ्लेक्शन एंड लॉ ऑफ रिफ्लेक्शन के दोनों पॉइंट वो एक्टिविटी आपको क्लियर हो जाने चाहिए. अभी तक अपन ने इतना ही किया. आगे भी हम टर्न होते नेक्स्ट थिंग में. पहेली एंड बूझो परफॉर्म द अबाव एक्टिविटी आउटसाइड द क्लासरूम. With the sun at the source of light instead of a torch, you too can use the sun and source of light. जहाँ पर torch use की गई है उस जगह पर आप source of light में sun भी use कर सकते हो, same activity को. Now next we move to our next point. Bujo remembered that in class 7 we have studied some features of the image of an object from a plane mirror. What is plane mirror? आप सुबह जिसमें आपके घर में जो भी mirror है प्लेन ग्लास के पीछे पॉलिश की हुई होती है तो उसको हम बोलते हैं प्लेन मिरर, है ना. आपने क्लास 7th में कॉन्वेक्स मिरर और कॉनकेव मिरर में जो स्लाइटली स्फेरिकल इन शेप होता है, ठीक है. तो पहले आस्क्ड हिम टू रिकॉल दोस फीचर. आप अपने मिरर के अंदर अपनी इमेज देखते हैं तो आपको उसमें क्या क्या चीजें दिखती है. पहली थिंग आपको ये क्लियर करना है कि उसमें आपको जो भी इमेज दिख रही है प्लेन मिरर के अंदर, व्हाट टाइप ऑफ ऑब्जेक्ट है. इट इज इरेक्ट और अपसाइड डाउन, सीधी होती है या जस्ट अपोजिट होती है, अपसाइड डाउन होती है. तो वी नो वेरी वेल कि जो प्लेन मिरर के अंदर इमेज बनती है वो क्या है बेटा, इट इज इरेक्ट इन शेप, मतलब वो इरेक्ट होती है. ओके, नेक्स्ट व्हाट इज ऑफ द साइज, सेम साइज एट द ऑब्जेक्ट. क्या जितने साइज के हम होते हैं उतने ही साइज की उसमें दिखाई देते हैं. यस. If did the image appear at the same distance behind the mirror as the object for in it. Suppose कीजिए कि मेरे बैक साइड में कोई फ्लास्क है और मैं अपने आप को मिरर में ऑब्जर्व कर रही हूँ, तो मिरर मेरे से आगे दिखेगा या बैक साइड में दिखेगा, बैक साइड में. तो जितना डिस्टेंस आप प्लेन मिरर के आगे की तरफ खड़े हैं उतना ही मिरर में आप उसके अंदर की तरफ भी सेम डिस्टेंस जो है वो शो होता है. Could it be obtained on a screen? जो प्लेन मिरर के अंदर जो इमेज है उसको हम स्क्रीन पे ऑब्टेन कर सकते हैं. नो, बिकॉज इट इज अ वर्चुअल इमेज. जो प्लेन मिरर है वो कैसी इमेज बनाता है बेटा, वर्चुअल इमेज बनाता है. ओके, नाउ we understand next activity.
Yes, James and I need to decide on a project on reflection in plane mirrors. We have a lot of reading up to do.
Well, try observing your own image to begin with.
What do you mean?
When you look into the mirror, is your image erect or upside down?
Erect, of course.
How about the size of your image?
Looks the same size as me. Also, at the same distance from the mirror.
Yes, that's right. You could depict these properties of images in your science project. I'll give you an example. Let's take the letter R and see how its image is formed in a plane mirror. Place the letter in front of a mirror. We can treat this as an object. We know that light from objects reflects from the mirror. Consider a point X on top of the object and a point Y at the bottom of the object. Let MN represent the surface of the mirror. From point X on the object, consider a light ray incident on the mirror at point A. According to the laws of reflection, the angle of incidence is always equal to the angle of reflection. Observe the angle of the incident ray as it reflects and travels to the eye of the observer. From the same point X on the object, another light ray is incident on the mirror at point B, and the reflected ray travels to the eye. The two reflected rays from A and B are divergent. When extended behind the mirror, these rays meet at X dash. Thus, the image of the point X on the object is formed at X dash. Consider one more point Y on the object. A light ray from Y on the object is incident on the mirror at C, and the reflected ray travels to the eye. Similarly, another ray from Y on the object is incident on the mirror at D and is reflected to travel to the eye. Like the two reflected rays from A and B, the two reflected rays from C and D are divergent too, and when extended behind the mirror, meet at Y dash. Thus, Y dash is the image of point Y on the object.
That's a lot of rays.
Yes, it takes a large number of light rays to form a reflection of an object. So, as you can see, rays from all points on an object are incident on the mirror and reflected in different directions. That is, the reflected rays are divergent.
So, how do they form an image?
All these divergent rays are extended behind the mirror to form a complete image of the object.
So, the image is formed behind the mirror?
Yes. That's why images formed by a plane mirror cannot be obtained on a screen. Now let me show you another interesting thing about images in plane mirrors. Raise your right hand.
Okay, sure.
What does the mirror show you? Which hand is raised?
Oh, I see what you mean. In the mirror, it looks like the left hand.
Now, observe the image of the letter R formed during the activity.
Same thing, the left side appears to be on the right, and the right side appears to be on the left.
That is because of the phenomenon of lateral inversion. The image of an object that you see in a plane mirror is laterally inverted.
Hey, I can see my image in the window pane too.
Yes, the laws of reflection apply to all surfaces.
But then, why can't I see my reflection on other surfaces, like a wall for instance?
That's because light rays incident on surfaces like a wall are parallel, but the reflected rays are not. This happens because the surface of the wall is irregular. The reflection from such irregular surfaces is called irregular or diffused reflection. The reflection from a very smooth surface, like that of a plane mirror or a plane glass, is called regular reflection. In regular reflection, a set of incident rays parallel to each other is reflected from a very smooth surface as another set of parallel rays.
Are you saying that images are not formed on irregular surfaces?
That's correct.
ओके क्लास, आई थिंक आपको प्लेन मिरर की जितनी भी इमेजेस हैं उनकी कैरेक्टरिस्टिक्स पता होंगे, फिर भी मैं एक बार वापस से रिपीट कर देती हूँ कि फर्स्ट image formed by a plane mirror, first one is the image in a plane mirror is of the same size and shape as the object. क्या होगा? Same size की same shape की object होगी. The image is a plane mirror is always erect. Okay, 2 point is clear to you. Okay, now move to third. The image formed in a plane mirror is virtual. जो प्लेन मिरर के अंदर जो भी इमेज बनेगी, इट इज अ वर्चुअल. वर्चुअल मीन्स द इमेज कैन नॉट बी ऑब्टेन ऑन अ स्क्रीन. ऐसी इमेज जिसको हम स्क्रीन पे ऑब्टेन नहीं कर सकते. इट्स ओके. नाउ द इमेज फॉर्म्ड इन अ प्लेन मिरर इज दैट सेम डिस्टेंस बिहाइंड द मिरर. जो इमेज के सामने जो भी ऑब्जेक्ट होगा वो सेम डिस्टेंस पे होगा. ठीक है. बिहाइंड द ऑब्जेक्ट एज द ऑब्जेक्ट इन फ्रंट ऑफ इट. जो भी ऑब्जेक्ट उसके सामने रखा होगा सेम डिस्टेंस पे हमें वो मिरर में इमेज उनकी दिखाई देगी. Next one is laterally inversion present in a plane mirror. Lateral inversion means our left side look in a mirror is right side look in a mirror left side. This property, this phenomena is called a lateral inversion. Okay, so I think you understand all the plane mirror activity. Activity 16.3. Okay, 1 second. Activity 16.3. Explain the whole image formation in plane mirror. कैसे plane mirror के अंदर पूरी images बनती है. We understand this activity in video. And what is lateral inversion? Here is a definition. It's a very important definition. A mirror that left of the object appeared on the right and right appear on the left. This is known as a lateral inversion. It's a very important point. Next point is regular and diffuse reflection. We discuss in next class. Okay.